Welcome to The Explainer. Today, we're diving into what is, honestly, the ultimate irony of human existence: our brain using its own incredibly complex machinery to try and figure itself out. We're talking about the most intricate piece of matter in the known universe. So, we're going to unpack exactly how it works, how it learns, and where all of this is heading in the very near future.
The physician Hippocrates once wrote, "From the brain come joys, delights, laughter, and sorrows, griefs, despondency." It's such a beautiful, humanizing thought that perfectly captures our conscious experience. Even thousands of years ago, early thinkers were already starting to realize that our entire emotional and intellectual world is housed right there, locked inside our skulls.
So, to make sense of this massive topic, here is our roadmap for today. 1. The ultimate mystery. 2. A brief history of brains. 3. Anatomy and dynamic networks. 4. Myths of the mind. And finally, number 5, the neurotechnological future. All right, part 1, the ultimate mystery. And it really is a vast challenge for scientists because to truly decode the brain, you have to zoom all the way from microscopic molecules and individual cells right up to sweeping cognitive behaviors and conscious thought. Which brings us to part 2, a brief history of brains. Because, believe it or not, it actually took humanity a really long time to realize what the organ inside our head even does. Picture this: you're an embalmer in ancient Egypt. What do you do with the brain? You literally scoop it out through the nostrils and throw it away. They honestly believed the heart was the true seat of memory and the soul, and the brain was just useless stuffing. Fast forward to the 4th century BC, and you have the brilliant Aristotle proposing that the brain was, wait for it, just a biological radiator meant to cool down the hot, seething blood from the heart. It wasn't until the late 18th century that scientists like Luigi Galvani, who you might remember famously made dead frog legs twitch with electricity, discovered that nerves act as electrical wires. This finally killed the age-old idea that our nervous system was just a bunch of fluid-filled plumbing tubes. But even before we knew how it worked, early humans were absolutely desperate to treat head ailments. This is wild. But 7,000 years ago, people practiced trepanation. That means they were boring literal holes into the skulls of living, breathing patients. Presumably, this was a physical intervention to cure things like headaches, seizures, or psychological issues. They definitely knew the head was vital, even if the underlying mechanics were a total mystery. By the 17th century, thinkers were desperately trying to bridge this gap between the physical body and human consciousness. René Descartes championed dualism. Basically, he theorized that humans have a spiritual mind that exists totally outside the physical body, but that it interacted with our brain's physical machinery through a tiny structure called the pineal gland. For Descartes, that little gland was essentially the physical seat of the human soul. Okay, moving to section 3, anatomy and dynamic networks. This is where we drop the historical theories and enter the modern biological reality of how our nervous system actually functions today. So the human nervous system is basically a sprawling, high-speed biological highway. Broad nerve wiring runs all the way through your body, zipping electrical signals at mind-blowing speeds from your toes up to your spine. But the main command center, that sits in the deeply wrinkled, highly specialized lobes of the cerebrum. And that iconic wrinkly shape is actually one of evolution's greatest packing hacks. Imagine trying to stuff 4 entire soccer fields worth of delicate neuronal membrane into the tight, rigid confines of a human skull. By folding and crumpling that tissue up, evolution maximized the surface area, giving us the immense computing power we need for language, logic, and complex thought. But just looking at the physical anatomy is kind of like looking at a computer monitor when it's turned off. We have to understand the wiring. Enter the Human Connectome Project, launched back in 2009. This massive undertaking completely revolutionized how we map macro-scale structural and functional connections in a living brain. Think of the connectome like a global map of flight paths lighting up at night. By combining cutting-edge MRI technologies, researchers could finally trace these glowing, long-range, complex routes. And for the first time ever, we could actively watch how those biological flight paths reroute as we age, or how they falter during neurological conditions. Now, the absolutely crucial point here is that this vast anatomical network doesn't just run on raw electricity. It uses chemical messengers, neurotransmitters, to run the whole show. And these chemical systems control literally nearly every vital body function you can think of. Your heartbeat, breathing, muscle movements, memories, sleep, and yep, even your digestion. To put that into perspective, just think about dopamine or serotonin. When you experience something rewarding, a cascade of dopamine rushes through specific neural pathways, physically making you feel that surge of motivation and pleasure. Meanwhile, serotonin is in there helping regulate your mood and even controlling movement in your gut for digestion. Because of their protracted actions, these tiny little molecules literally orchestrate our entire emotional states and sweeping behaviors.
Let's pivot to Section 4, Myths of the Mind. It's time to tackle a few massive historical misconceptions and debunk some of the biggest classical myths about human cognitive development. First up is the major myth that adult brains are basically fixed, non-modifiable structures. For the longest time, early neuroscientific models taught that once you grew up, your brain was just set in stone. The actual reality? Neuroplasticity. Your brain is constantly rewiring its physical structure based on your daily habits and experiences. Learning a new language, forming a memory, recovering from an injury, all of that is driven by this ongoing neural reorganization. Actually, your brain is actively reshaping itself right this very second, just by processing what I'm saying. We also seriously have to rethink how we view babies. A prominent classical myth pushed by thinkers like Freud and Piaget was that newborns are isolated blank slates, totally disconnected from external reality. But modern research shows something totally different. Scientists like Andrew Meltzoff revealed that infants have innate imitation abilities. In some incredibly famous experiments, researchers simply stuck their tongues out at newborn babies. Some were literally only hours old. And astonishingly, the babies mimicked the facial gesture right back. They were actively mapping their own unseen bodily movements to the observed acts of others. So they aren't isolated blank slates at all. They arrive in this world actively wired to connect socially. Finally, Section 5, the neurotechnological future. Let's look forward and examine how our deep understanding of the brain is leading to some truly mind-bending innovations by the year 2026. Right at the center of this revolution is the BCI, or brain-computer interface. This has become a commercially viable and clinically validated domain that is rapidly reshaping how we interact with machines, how we recover from neurological injury, and how we augment our own cognitive performance. By 2026, BCI's crossed the line from a cool experimental novelty to practical infrastructure for millions. Just imagine a paralyzed patient who can't physically move their arms. They just think about moving a computer cursor, and the BCI instantly translates those neural thoughts directly into digital actions on a screen. This technology is unlocking totally new worlds for people globally. But the goals extending beyond 2026, they are even more incredible. We are moving way beyond just restoring lost motor function. Future frontiers include whole cortex recording using something called neural dust. These are microscopic, wireless nanoscale sensors injected into the brain to monitor activity from the inside out. Researchers are also exploring holographic optical neural interfaces, which use light to read and write brain activity with absolutely unprecedented precision. And perhaps the wildest part? Collective neural interfaces. That's a very advanced way of saying AI-mediated brain-to-brain communication, where thoughts could theoretically be shared directly between individuals. We're talking genuine, next-level cognitive augmentation. But as you can probably guess, with this unprecedented power comes some massive governance gaps. Managing the ethical risks of all this means we have to secure neural data privacy, guarantee cognitive liberty, and ensure equitable access globally. Because think about it, if neural signals can literally reveal your unexpressed thoughts and intimate intentions, we desperately need urgent legislation to protect people's inner lives. Interestingly enough, the nation of Chile actually pioneered this effort. Way back in 2021, they proactively passed legislation to enshrine neural data protections directly into their constitution, ensuring that the contents of a citizen's mind remain their own sovereign property no matter how advanced this tech gets. Which brings us to a final, pretty profound question. Will whole cortex recording and collective neural networks fundamentally change what it means to be human? If we start merging our biological brains with advanced digital networks, translating our innermost, unexpressed thoughts into external realities, do we redefine human consciousness entirely? It's a fascinating, heavy question, and one I'm going to leave you to ponder as we continue to unlock the ultimate mystery of the human mind. Thanks for joining me on this explainer, and keep questioning the incredible machinery inside your own head.